Okay, so for problem number 8, it might be a little bit harder, but it's similar to number 7. So if it says cosecant is negative 11 over 6 and cos is greater than 0, meaning it's positive, I like to work with sine and cosine. So I just take the cosecant and I pretend that it's the sine of theta, which is negative 6 over 11. We're allowed to do that because we're referring to the same triangle. So we look at one restriction at a time. If we know all students take calc, we know that all are positive in first quadrant, and if this is a negative, we got to cross it off. Okay, in the next quadrant, sine and cosecant are positive, so it can't be here if sine is negative. That means that we are in quadrant 3 or quadrant 4. So now we use the second restriction to decide which between 3 and 4 it's in. Now looking at the second restriction, it says the cosine is greater than 0, meaning it's positive. Okay, in quadrant 4, the cos is positive, so it's got to be in quadrant 4. It can't be in quadrant 3 because only tan and cotan are positive, and cos is not positive in quadrant 3. So we know we're working with quadrant 4. So let's draw a triangle there. So if sine is opposite over hypotenuse, we know that we have opposite. We know that we have a hypotenuse. Don't worry about the positive negativeness yet. So opposite of theta is going to be a 6. Our hypotenuse is going to be an 11. And when we look at this triangle, we know that to the right is going to be a positive value. We know that going down is going to be a negative value. And we know the hypotenuse is always going to be positive. Oops, that's positive. So now we need to find this adjacent side using Pythagorean theorem. When you do that, so you have hypotenuse 11 squared equals a squared plus b squared. And when you isolate a, you get a is equal to the square root of 85, and that doesn't simplify, and we know it's positive based on the location of this triangle. The location is critical when you think about the signs. Okay, so now let's fill this in. So for sine, we have our triangle. It's opposite, which is negative 6, over the hypotenuse, which is 11. For cos, it's adjacent, which is square root of 85, over the hypotenuse, 11. For tan, it's opposite, so it's negative 6 over the adjacent, square root of 85. I'm going to simplify in the end. So now we're just going to flip all of these for their reciprocals. And then we just need to simplify. So it looks like tan and secant we have to simplify by multiplying by square root of 85 over square root of 85. So I'll show you those simplified answers over here. So then when you simplify those, the secant is 11 square root of 85 over 85, and the tan is negative 6 square root of 85 over 85. Okay, so for the next problem, you basically first plot your ordered pair, negative 7, 12. Then we're going to draw a line to the origin, and we're going to create a right triangle. And we're going to put theta between that terminal side, the hypotenuse, and the x-axis. Now, based on location and what was given, we can label. So x, or to the left, 7 units, and we go up, or y is 12. And then we just need to do Pythagorean theorem to find this last side. And when you do Pythagorean theorem, you'll get square root of 193, which doesn't simplify. Okay, so then when we're looking at all of these, we know sine is opposite of our hypotenuse, so we know that 12 is opposite, and we know the hypotenuse is square root of 193. We know cos is adjacent over hypotenuse, so our adjacent's negative 7. Our hypotenuse is square root of 193. Tan, TOA, is opposite over adjacent, so we have 12 over negative 7. Then we're just going to flip for the reciprocal. So when you look at these, the only ones that we're going to have to simplify, we're going to have to simplify sine, and we're going to have to simplify cosine, and that's it, because there's a radical in the denominator. And when you do that, I'll put these answers right here, simplified form. And then when you simplify, again, you'll get for sine, 12 square root 193 over 193, and for cosine, when you simplify, you'll get negative 7 square root 193 over 193. Notice, because we're in quadrant 2, all students S, only sine and cosecant should be positive, and the rest should be negative in quadrant 2. So for the first one, if it says, what's the reference angle of 7 pi over 6, I just convert to degrees, 210, and then I'm going to see where 210 degrees is. So I know this is 90. I know this is 180. Okay, so I know we're right in here, between 180 and 270. So 180, and I have to really think, 180 plus how much is 210? So you could think of it as 210 minus 180 is 30, right? So this angle right here is 30. Because again, from 180 degrees to 210 degrees, you're adding 30 more. Now, a reference angle is wherever your terminal side to the x-axis. It's that angle between. And so in this case, it is 30 degrees. But if we ask you to put it in radians, you need to make sure that you have it in radians. You can always convert back if you forget. And you'll end up with pi over 6. So that's it in radians. Okay, so for 480, we first want to see the location. So it's more than 360, so we know we're doing more than a loop. So we're going to subtract a loop, and we're left with 120 degrees. So we're going to go to this spot, because you loop around once, and then you add 120. So that's where we stop. So 360 plus 120 more. So it's 90, and 90 plus how much? So right in here, 90 plus what gets you 120, or you can think of it as 120 minus 90 is how much it gets you that one spot. So since that gets you 30, we know that spot from right here to the terminal side, we know that that is 30. Now you have to ask yourself, is my answer 30? No, your answer is not 30. Unlike A, remember, your reference angle is between the terminal side and the x-axis. 30 degrees is not. So you have to find that reference angle. It's 90 degrees minus 30 degrees. So your reference angle is 60 degrees for B. Or you could write pi, over 3. Okay, so for C, I just converted negative 15 pi over 3 into degrees, so it's negative 900 degrees. So what I did is I kept subtracting 360 because you keep looping around, and when you keep looping around, even if we go in the negative direction, right? So negative 360, we land right here. Now, if we land on the x-axis, it's 0 degrees. There's no angle. This terminal side is touching the x-axis, so our reference angle is 0 degrees. It's 0. Okay, so for negative 120, I know that this is negative 90. I know that if I do another 90, I'm going to be at negative 180, right? So I know I'm somewhere in here. So I say to myself, negative 90, and what gets me to 120? We'll just think about it as the number 90. 90 plus what gets me to 120? Where would I stop? So right in here, 90 plus what is 120? It's 30, right? We could just throw a little negative in there. But it's 30 degrees. Now, the reference angle has to be positive. And it's not going to be 30 degrees. It's going to be 90 minus that 30 degree difference, right? So it's going to be 90 degrees minus the 30 degrees. So our reference angle right here is 60 degrees, because this is not, 30 degrees is not from the terminal side to the x-axis. So 60 degrees is our answer. Okay, now lastly, these ones are easy, right? So we just put them in our calculator. Just be careful. So A is radians. We know that C is in radians, and we know that D is in radians. So I would set my mode to radians. This one, you just pop in sine 1.76. Just make sure it's in radians, 0.982. Let's go to C, because that one's also radians. So for C, right, you don't have that cotan button, but you work with tan. So it's 1 over tan of 2.33, which ends up as negative 0.9489. Then let's do D. So cos of 2.1, you just hit cos 2.1. It's in radians, so you get negative 0.5048. Then you change your mode for B and E into degrees. Make sure your mode's in degrees. So for cosecant, it's going to be 1 over sine of 126.7. And when we pop that in, we should get 1.247. And then for E, it's 1 over the cosine of 574, which is equal to negative 1.206.